till now we covered the base, like how did PCI Express protocol got evolved. We discuss about RS-232, PCI and PCI X protocol, and what was the need of a protocol like PCI Express. And then we move on to the architecture where we learned about the basics of topology, and we learned do how various layers of PCI Express works. That was just a basic overview. We also learned about TLP, DLLP, assembly and disassembly. So today we are starting a new chapter, that is enumeration. So let us get started with enumeration now. So anyone went through this concept before? So
at time, like what sort of device it is connected or kind of information it might get to the PCI. So that process is called as enumeration, I guess.
yes. So
So
when
means
the yes,
this is one question. See, there is a two types of there. There is a BD. I forgot that bar register. When the release means when the boot time, this configuration setups. I think correct.
yes,
Yeah, the boot time. There are some bar register. They identify the source. Some vendor ID. All are registered. So there is a uh, what plugin, right? At the time they configure this, there is a request, right? Completion transaction request is there, right? They transfer this BAD bar register, correct?
yes.
Okay.
So would anyone like to speak or should I start? So when the system powers on, it goes through a process called as enumeration. So where it discovers all the connected devices like graphics card or network cards and assign the bus numbers and system resources. So this process in PCIe works just like it worked in older PCI system. Once enumeration is done, the software has a clear map of devices in the system, making it easier to manage them. Now, in so why this is useful? So by organ, so So enumeration is a key process that happens when the system starts up. During enumeration, the configuration software scans the system, identifies the connected devices, and assigns them bus numbers and system resources like memory and IO space. So in PCI system, even though the internal setup might be complex with switches and multiple buses, the enumeration process works the same way as it did in PCI. Once the system is done with enumeration, each device and bridge gets a bus number and can now communicate with the rest of the system. So this is important because enumeration ensures that every device know its place in the system and how to route the transactions. So what happens when you boot your PC? So would anyone would like to answer this?
Those that whatever the PCI have connected, right? That ports the configure that with the help of bar register, they configure that through of I forget that memory write, memory read, some packet trigger is there, right? I forget completion or something is there, right? That packet they generated, corresponding the packet they configure that UR endpoints. What are the endpoints is there? They configure. So they identify that, oh, this is the type 0 or type 1 or whatever the header. They
Yes.
identify this is a endpoint, or this is the bridge, or this is the switch. They identify that at the boot time. They configure these things.
Yes. So once the system is boot up, first thing that each link, each device, each function gets a unique PDF. And root complex is aware of these ranges. And configuration header, that is 256 byte to 4 KB space, will be accessed using configuration write and read TLP. So these TLPs consist of target device BDF numbers. So what is BDF? Bus.
I have hello. I have one
Yes.
doubt. So
Yes.
whether the configuration has been done by BIOS or which one? Whether it's by RC or it's by switch or it's by CPU.
I think it is by the root complex. Am I right?
I don't know. So I'm just asking that question. I thought it's from CPU or it's from the BIOS.
It should be from the BIOS
So
actually.
BIOS will
What
configure those root space. I mean, yeah, configuration space. BIOS will
correct?
access that configuration space of the endpoint, and after that, uh,
Right
BIOS will get
now,
to.
I don't know that one is actually. So bias some is there. So whatever the basic drivers, the installation, right? So at the time there is a any driver initialization at the time. Maybe if you, for example, PCI driver is there, they configure this type of because if you configure that type of RC like sorry endpoints, there is a BAR means some register is there. Some register this format
Bar
they
registers are
register.
ba- yeah, bar registers are already programmed by RC, right? Or sorry,
Exactly.
bar registers are already programmed by BIOS. After that only,
Yeah,
RC will
this
RC will
bias.
get to know.
See, once the basic driver initialization, they understand the format. If your driver is not understand what is that bias, nothing but driver's initializations only, right?
Yeah, correct.
Yes. So let us now start with bus. So PCIe supports up to 256 bus numbers, so which are assigned by configuration software. So the bus, so the first bus, typically bus 0, is associated with root complex, and it includes virtual PCI buses and bridges, or you can say P2P bridges. So these bridges can extend the bus hierarchy, allowing additional PCIe devices to connect. So bus numbers are assigned through a process called depth first search. So we will learn about it later. So where configuration software starts at bus 0 and assigns unique bus numbers to each bus it finds. Then we come to device. So each PCI bus can support up to 32 devices, which is device 0 to device 31. How each PCI bus can support up to 32 devices. So, however, due to the point to point nature of PCIe, only one device is directly connected to PCI link, and this device will typically have the device number 0. So devices may reside on virtual PCI buses like those in the root complex or PCI switches, so which can support multiple attached devices. So each device is expected to implement function 0 and may support up to 8 functions, which is function 0 to function 7. So a device that support multiple function is called as multifunction device.
Will assign BDF number, right?
So now let us start with functions. So each device can implement up to 8 functions. So functions represent specific hardware interfaces or controller. Example, hard drive interfaces, display controllers, USB controllers. So functions do not need to be sequential, meaning a device could implement function 0, function 2, and function 7 while skipping others. So each function has its own configuration space, which the system uses to manage the resources allocated to it. So, what do we mean by configuration space? So, let us get on to that. So, let us understand why do we need configuration header. So, so root complex should know everything. That is what type of device, like you have connected a printer to your PC. So to communicate with the printers, the root complex should know everything. That is the type of device, who is manufacturer about that device that is connected to it. So the entire information is implemented by means of configuration headers. So once the root complex figures are out what type of device it connected, it will get the required device driver in the memory. So RC will use these driver instructions to communicate with the device. Okay, so any questions on this? So let us now move on to the configuration space. So PCI and PCI X, all peripherals are IO mapped. That is, all transactions are done to these devices using the IO rights. In a, but this method is inefficient because each address need to be addressed individually. Whereas in PCIe, all peripherals, memory, and configuration header is memory mapped. So all transactions that are done to these devices is done using memory writes and memory reads. So configurations space registers are mapped to the memory locations. So device driver and diagnostic software must have access to the configuration space, and operating system typically use API to allow access to device configuration space. So what is configuration address space? So in early days of computers, when you installed a new device like a sound card or network, you had to manually set switches and jumpers to computer how to use it, to tell the computer how to use it. So this was like putting together a puzzle without clear instruction, and it often led to conflicts which were two devices tried to use the same memory for IO ports or interrupts and tell the CPU to do something. So it was pretty complicated. And later, the system got smarter with plug and play technology, which made it easier for the computer to figure out how to use new devices automatically. But the things really improved with PCI system. So PCI introduced a new way to automatically manage all the resources like memory, IO. So that each device so so without con- so that so with this we can now automatically manage all the resources that devices needed without conflicts, and it was all because of configuration address space. So when we talk about configuration address space, we are referring to a special block of memory that PCIe reserves for each function of a device. So remember, function is just a specific job a device can do, like handling audio or controlling your mouse. So this space holds important register that allow that allow the computer to detect the function, configure it to work correctly, and check the status. So whether it is working fine or if there is problem. So each device function gets its own dedicated space to prevent overlap with other devices, meaning no conflicts. So, in summary, configuration address space is special area of memory where each PCI system get its own set of settings called registers, so that help computer detect, configure and manage the device. So originally each function have 256 bytes of space. As you can see here, we have 256 bytes of space. So, but modern devices needed more space. So PCIe expanded it to 4 KB per function in the form of extended configuration space. So this space helps avoid conflicts and allow modern computer to automatically manage complex devices without needing manual setup. So, PCI's configuration address space is like a control panel that tells the system how to manage all the devices to it, making sure everything works smoothly and without conflicts. So, the configuration space consists of device ID, as you can see here, which is assigned by the vendor, and the vendor ID is assigned by the PCI SIG, which we talked in very first lecture. And then status register, so it report which features are supported and whether certain kinds of error occurred. And then we have header type, class code, which identify the types of devices. Example, it is a storage controller or a display controller. And we have extended configuration space, as you can see here, just 192 bytes. So it offers PCI power management capability, MSI capability registers. So let us now understand it. So when PCI was very first designed, every function got 256 bytes of configuration space. So these 256 bytes were enough back then because devices did not need lot of extra features. So the first part of the space called the configuration header, which is the first 64 bytes, is used to set up the basic functionality of device. So there are two types of header. The type 0 header for most of devices and type 1 header for bridge devices, so which connect the buses. And the remaining part of 256 bytes is, so the remaining 192 bytes are used for optional features like adding new capability to device like power management or hot plugging support. So, as evolved, new devices needed more capability. So, the original 256 bytes could not handle it, so which was extended. So, PCI introduced extended configuration space, which is 4 KB or 4096 bytes per function. So this space allows PCI devices to include extra registers that give them more powerful and flexible features like advanced error reporting or extra power management. And then, as you can see here, so this is PCI extended space, which is only accessible by PCI enhanced configuration and access mechanism, which we will learn about this later. So it have advanced error reporting, virtual channels, device serial number, and power budgeting. So this yellow part you can see here. So this is accessible by legacy PCI software or PCI enhanced configuration access mechanism. So we will learn about these mechanism later when we will study about various methods of accessing later. So this is the PCI capability structure which must be implemented in the register space. So let's get so
Yeah.
after
A small question.
yes.
That configuration header, can you show me once back? Yeah. The blue color indicates from means, so when the BIOS they configure, right? This correct?
Yes.
When the okay, got it.
Okay.
That's it.
So let us now understand the rules of assigning the BDF assignment rules. So number always start from RC level. That is, it is always start from with 0. As you can see here. So here also you can see, so this starts from bus 0. So root complex internal bus is assigned with B0. So first device enumerated on any bus number is numbered as B0. So so this is the first device of bus 0.
The PCI.
Yeah. So acknowledgement only gives like the packet what is receiving at data link layer is correct or not. That's it. Nothing to do with
Yeah.
the read write transaction. Okay. So just remember one point. Whenever you're going to read something, right? Read data,
Yeah.
it will form
Okay.
two TLP, one from the
Yeah.
sender
Yeah.
side, one for the
Yeah.
receiver side. Okay.
Yeah.
So sender
Yeah.
will send, hey, I want address, particular address data. Sender
Yeah.
will say, hey, sir, this is my address and this is the data. So two TLP
Yeah.
will get.
Yeah. That is
Okay.
for non-posted. They have
Correct.
two LPs.
Yes. And when
So
posted
posted
means
have
just
only
fire
one
and forget.
PLP.
Yes.
Yeah.
Only one TLP. So host will say, okay, go to this particular address and write the data. Okay.
Okay.
So it will go there and write the data. So some of the BIOS is having some features, something like a you comes to know something called DMA. I mean, direct memory access.
Direct memory access.
Yeah. So what happened, right? They are having the addresses, right? They are storing the addresses itself so that the transaction will be a bit faster compared to the normal transaction. So
Yeah.
it
No,
will look for
similar to
the address.
RC, whatever the RC they're doing, similar to DMA also same thing.
No, DMA is
Correct?
different. DMA is a different engine. It will sit on the RC.
Yeah.
Okay.
Yeah.
DMA you can use for the multiple thing. It's not specific to any PCI or anything. You can use for the
Okay.
where you can hold the address of the memory location.
Okay.
Okay.
Yeah.
So
Okay.
let's suppose you stay somewhere in society. In your society we have 10 flats. 0, 1, 2, 3, 4, 5, 10. Okay, so you are DMA because you have address of all the 5 10 flats. So someone
Okay.
come and ask, hey, I need to go to the address flat 11. You will say no, this flat is not there, right?
Yeah.
So the same way DMA is working, like they are having holding the address range. So this is address
Okay.
for the PCI DDR location where you have to go and read and write all the things. So there, if you go, let's suppose you want to write something on particular location. So let's suppose that location is not valid. Okay,
Okay.
then it will not get any. It will not send any acknowledgement, right? Ki this
Yeah.
address is not valid or something. No.
They're showing some error only.
Yes, so
Correct?
so so there the application comes in the picture that will pop up the error message. Ki, hey, this address is not valid. The DMA will come
Okay.
in the picture and say like, okay, this address is not valid. Then you
Okay.
will again reconfigure a TLP and send on some different address,
Okay.
right?
Right. Got it. Thanks, Ami.
Yeah.
So is this my screen visible to you all? Are you able to
Yes.
understand what is
Yes.
written here?
Yes.
So yes. So number always start from the root complex level, which always start with 0. So here is we have bus 0, and here we have bus 1. This is 2, and this is 3. This is 4, 5. So so bus numbering always happen in depth first search manner. So here what we can say how depth first search manner is working here. So this is the depth first search manner. So we will number the bus numbers in this order first, and then we will move to this here. And after numbering that, we will order the buses here. So in that manner, it our this bus number, so this will be assigned bus number 6, and this will be 7. Any doubts on this? So first device enumerated on any bus number is numbered as D0. So this is numbered as D0 because it is the first device enumerated bus to the bus 0, and first function enumerated on any device is numbered as F0. So here we have device 0 and device, so so the device 0 have two functions, that is function 0 and function 1. And to and as we know that the according to the rule that first device enumerated on any bus is numbered as D0. So this is the bus number 1. So we have enumerated this device as D0. And this is the P2P connections, like that is why we, so this is the P2P connection. So this is the device 0, device 1, device 2, and each have their function 0 because first function enumerated on any device is F0. And here, so what will be the BDF for this device? So 3 is the bus number, device number is 0, and function number is 0. So PDF will be 300 for this. So let us take one more example for this. So this one. So here our root complex starts from here. So this is our bus 0. Now we will follow the depth first search rule. So this is the bus 1, and this is the bus 2 here. Here is the bus 3, and here, and according to this is the bus 4, because we are using the depth first search rule here. And here is the bus 5, bus 6, bus 7, bus 8, and so here is the bus 9, and here is the bus 10. So any questions on the BDF? Is Was my explanation clear to you all? This is the device. Here is the bus 5, bus 6, bus 7, bus 8, and
This is the switch architecture, right? So so what happened, right, in switch architecture? uh, your when host will, so when you on the host, right, when power on the host, it will scan your physical electrical connection, right, slot, what you call it as a PCI slot. So there it will look for the device. Okay, if any device is there, then it will assign some number, zero one thing something, it will assign. Then it will look for, like, if there any connecting device is there, like a switch you have shown, right? So I'm just taking the example of the left hand side PCI switch. So it will go there. Okay, and from there it will assign a device 0 1 2 you have, and function also it will change, like on which bus it is, it found, what is a device, and what the function of particular things. So once you give this three information, right, the host will comes to understand like where the device is. This is called a PCI tree. Okay, so host will comes to understand like on bus 0 or bus 1, device 2 want to communicate with me. Okay,
yes,
if switch is not there, directly you can see, right, directly you can give 0001. So on bus 0, device 1 want to switch, want to communicate with me. Here, since we have one more layer, right, of switch, that's the reason bus is an ID is getting changed now. Well, 01 is getting changed. So how it assign like a, I mean, a host will comes to understand from the BIOS, like, okay, I have started with 0. There is one more branch. That's the reason my bus number is getting changed from 0 to 1, or 0, sorry, 0 to 1, or 0 to 2, or 0 or something. So the 1 2 3 will define how many hierarchy is there, like how many number of endpoint is connected, or how many switches connected there.
yes.
Okay.
So the process of root complex is to detect all the connected PCI devices and exchange the configuration header. So exchange the configuration header information. So root complex device 0 and device 1. So here we have the root complex device 0 and device 1. So these are not the endpoints, they are a bridge type. That is, they are the PCIe to PCI virtual bridge. So all devices attached to the downstream of a PCI link. So this is a PCIe link. This is also a PCI link. So all the devices attached to the downstream of the uh, P, uh, PCI link must be device 0. So as you can see, this is also device 0. This is also device 0. Here also it is device 0. This is also device 0. Like, so PCIe link is a point to point connection. So and P2P bridge is required either in root complex or in switch to connect multiple devices. However, connection among P2P bridges, either in inside root complex or inside switch, is multi-drop. So PCI enumeration assigns bus number to each PCI link and P2P bridge. So let us now understand how to assign this secondary bus number and subordinate bus number. So what do we mean by secondary bus number? So it is the minimum bus number in the tree under the bridge, and sub bus number is the maximum bus number in the tree under the bridge. So this is the bus 0, and this is bus 1, this is bus 2, So as you all know, we in ordering the bus number we use the depth first search method. So we will order the bus numbers like this, and then we number this one, and then like this. So bus 4 here, this is bus 5, this is the bus 6, bus 7, bus 8, bus 9. So how we will order the subordinate and secondary bus number? So like for example here, so this device secondary number is 1 and subordinate is 4. So the minimum bus number under this device is bus 1. So its secondary bus number is 1, and the maximum bus number under this device is 4. So the secondary bus number is 1 and subordinate is 4. And similarly, let us try for this one. So the bus number under this device is the bus 2, and the maximum bus number under this is 4. So 2 and 4, where 2 is the secondary bus number and 4 is the subordinate bus number. So as you can see here, this is the P2P bridge. It is given here, and here, as you can see here, the minimum bus number is also 7, and the maximum bus number under this is also 7. So the secondary bus number is 7 and the subordinate bus number is 7. Both are same. Here, the minimum bus number below this is 5 and the max is 9.